Let's understand some possible errors that can occur when you're performing an experiment. So some of the most common errors that can occur are the zero errors, the parallax error, and the response time error. Let us understand each of these errors one by one. Let us start with the zero error. Alright, when you look at this picture here, you see a ruler. What are you trying to do here? You're trying to find the length of this object, this blue color object. Look at the screen carefully and tell me what should be the length of the object. Is there any mistake in the measurement? And what should be the length of the object? If I say that the length of the object is 16 centimeters, is my answer correct? Obviously no. You all know how to use a ruler. When you're using the ruler, the zero mark of the ruler should coincide with the starting point of the object. The object should be placed something like this, or else you will get zero error and your reading will not be correct. So what is the correct length of this object? The correct length of this object is 15 centimeters, right? Sometimes your measuring instrument might not be precise, right? Say for example this ruler, it's broken, it's chipped off at the beginning, it is broken at the beginning. So you are forced to take measurements starting from say a point which is not zero, say 1 centimeter. You're forced to take readings. All your readings in your experiment you are taking from 1 centimeter onwards. You have noted down all the readings, you have created a table, but are these your final readings? No. So you have to be careful. You have not started from the zero mark on your ruler. So please adjust this in your readings to get the final set of correct readings. So this is very common sense and very easy to understand. This is your zero error. Now let us move on. Let's now understand about the parallax error, which relates to your line of sight. What is line of sight? Line of sight is nothing but a line. It is a straight line. It comes out from your eye. So why is line of sight a straight line? Common sense. How do you see things? You see things because of light coming from the object and entering your eye. And the light always travels in a straight line. So line of sight is a straight line, right? So suppose that you are trying to take down the length of this rectangular object. You can look at the ruler from various different angles. So here for example, I have taken two locations, location 1, location 2, right? Say that your head is at location 1. Let's draw the line of sight. The line of sight goes something like this, right? You are noting down the reading, which is 15 centimeters, and it is a correct reading. Now let's draw the line of sight when you're taking down the reading from position 2. Let me use a different color now, and let's draw the line of sight. Now you have a different line of sight, and it is coming on and falling on the ruler somewhere near 16 centimeter. It's coming out to be 16.2 or 16.1 centimeters. So which is the correct reading? The correct reading is the reading when your eye is at this location. So what is the difference between the red line of sight that you see here and the green line of sight? If you notice carefully, the red line of sight is at a 90 degrees. The red line of sight is at a 90 degrees angle with the ruler. So this is very, very important. There can be multiple line of sight depending on from which location you are looking at the ruler. So your eyes can be anywhere around the ruler. Your eye can be at location 2, or your eye can be somewhere here, Your eye can be somewhere here, your eye can be anywhere, right? But which is the correct position for the eye to take the reading? When the line of sight creates a 90-degree with the ruler, then you'll get the correct reading. So don't be lazy when you're performing the experiment. You'll have to move your head around to note down the correct readings. Otherwise, your readings will be wrong. So if you have to take the reading at the two ends, end 1 and end 2, you have to move your head all the way, right? You have to move your head all the way from this location and come all the way to this location. You cannot be static at one location and keep looking one way and the other way to note down the readings. You have to keep moving your head around so that your line of sight falls perpendicular to the measuring instrument, right? If you do not do this, it leads to the parallax error. So parallax error can occur in many different ways as well. I have one more example here. So what are we trying to do here? We are trying to find the depth or the length of a liquid column. The liquid column, whenever they are held in a tube, they form a curvature at the top. So the curvature can be a convex curvature or it can be a concave curvature depending on the property of the liquid, right? And how do you take down the reading of the level of the water? It is through the meniscus. What is the meniscus? Meniscus is the topmost point of the curvature or the bottommost point of the curvature, depending on if the curvature is a convex curvature or the concave curvature. Now let us come to this picture. So which reading is correct? So clearly, now that you understand, in this scenario, the line of sight that goes all the way to your meniscus, it creates a 90-degree with the measuring instrument. So this reading is correct. There is no parallax error. However, if you look at the eye position, which is this and this, the line of sight all the way from the eye to the meniscus is not 90 degrees. It's not 90 degrees. So therefore these readings are wrong. So you are getting parallax error for these two locations of the eye, and the reading is correct when your eye is at this location. The line of sight is perpendicular to the measuring instrument. So I hope you all understand parallax error. So now the third kind of error that we have to understand is the response time error. Let us understand it with the help of an example. Suppose that you are given a pendulum and you have to find its time period. What is time period? The time period of the pendulum is the time taken for the pendulum to complete one oscillation, right? Suppose that you are holding the pendulum on one end. You have the stop clock in your other hand. You start the stop clock as soon as you leave the bob from your other hand. The pendulum swings, goes all the way the other end and comes back to the same location, and you stop the stop clock. All this process will happen quite quickly. So do you think that your brain will be fast enough to stop the stop clock on time? On time means as soon as the bob reaches the original position. So human body is a complex system. It takes time to process information. So how will your body work to stop the stop clock? Your eyes will see that the pendulum has reached this location. The eyes will send a signal to your brain. The brain will process the information. The brain sends the signal to your hand to stop the stop clock. So all this process takes some time, and because of which there will be a delay in stopping the stop clock, and it leads to response time error. The response time error is related to your time taken to respond to a particular event. It is a very common kind of error. So how do you avoid such kind of a error in this particular experiment? So what do you do instead? You do not time one oscillation because that will be quite quick. Instead, you time 10 oscillation. You can repeat the experiment also 3 times, 4 times, 5 times, depending on how much of a time you have. Say that you're doing the experiment for the first time and you timed 10 oscillation, which is easier to time. Say that you timed 10 oscillation and it came out to be 5 seconds. You repeated the experiment the second time and say that the time for 10 oscillation was now 5.5 seconds. All the readings are taken in seconds. You repeated the experiment for the third time and you found that the time period for 10 oscillations was 4.5 seconds. So what do you do next? You find the average of the 10 oscillations. Find the average, add them all up, divide by 3. So the average should come out to be 5 seconds. This is the average for 10 oscillation. How do you find the time for the 1 oscillation? Simple. 5 is the time for 10 oscillations. So the time for 1 oscillation is 5 by 10 or 0.5 seconds. So that's how you limit the response time error in your experiments. So in this video, we have understood about the 3 kind of errors. If you still have any doubts or need some clarification, please type in the chat box and let me know.